Um, Good morning or late good morning to you. My name is Rudolf Stachel. I'm also coming from NBG in Austria. And as my colleagues have already presented to you applications and the points of using fiber optics for sensing, I will monitor a special use and a special application in the future, which is not yet that well developed as the applications my colleague David presented to you. But as fibers have special advantages, it's very interesting that we can use the fibers in ultra-high temperature monitoring. So the content of my presentation will be why are we using the fiber optics in this area, what are the uses, what are the applications we can think of, because it's different from the telecommunications and all the sensing so far. What are the advantages my colleague presented already to you? A small comparison of the fiber optic sensors to the electric sensors. Some of the challenges we will face in the ultra-high temperature usage. What is the actual development status? Because these areas are not yet very much used in reality. And these solutions require certain points which must be developed. Fiber optic sensing, the measuring principles, I want to stress once more. And our focus, which we will have in future, on this ultra-high temperature industry. So, why are we using fiber optic sensing? So there are a few physical reasons the fiber optics are providing. Once they are extremely small. If we think of some of the applications we can use it, the small parts are very critical because they do not take any space. The large temperature scale, up to 1000 degrees, they are very interesting for industries, like in the metal refinery, in the power stations, and so on. And the robust design and high physical stability is needed in all these harsh environments. But there are also some sensing advantages the fibers can provide. The high sensitivity and fast response time. It's critical for furnaces to detect changes. But what is also very helpful for improving processes in the industries, in the manufacturing industries, in the process industries. It's that we can detect and monitor by one fiber different sensors. And one of the most important advantages in these areas, because at temperatures above 600 and 800 degrees, the problem is to bring electricity to points of sensoring. So why are we using fiber optic sensors? All in the manufacturing industry is about improving processes. So far, a lot of these processes cannot be monitored, so only the results or the damages can be monitored or can be seen, but you can't monitor and improve the process itself during the time, because it's not so easy to measure and monitor the changes. So the input we can bring from the data which we measure are a very new field, and a lot of development can take place. Especially for the avoiding the damages in these furnaces. If you can imagine a power plant not using the oil, but maybe wooden flakes or something like this, you get a lot of ash deposits, for example, on the top of the furnace. And up to now, it's very hard to detect the thickness of these deposits. But once the deposit is very high, it drops down and it can hurt the furnace. The same in the oil pipelines, for example, to avoid the blocking within the pipelines. You cannot monitor these so far, but we are working on these sensoring systems to be able to detect the blockage of these pipelines. Starting with this, all these data which we can provide to the customers, they can control the maintenance. It's easy to monitor wear and tear. The life cycle management of the whole furnaces can be improved a lot, and also the service planning. So just imagine if you run down a whole manufactory for 2 weeks a year, if you can extend this to a circle by, let's say, only once in 3 years instead of every year, so this could be a big advantage. So measuring the temperature itself is also a very important point for these applications. And we can measure the temperature in distributed way. So there are up to now thermocouple measures can be done only point-wise, but we can do it on a distribution. And the effects of this influence of the temperatures, they can bring the improvement in the monitoring and in saving money at the last point. So in which areas generally can be used these sensing? Materials and equipment test labs, in the energy power points, power stations, in industrial areas, which we are focusing right now on. Ovens, heaters, furnaces, and boilers, which are used in vast industries. We have the power plants, we have turbines in airplanes, and we have combustion process, deep well oil and gas exploration, which spend a huge amount of money to be able to detect changes down very far down in the earth. One practical example we have done is the coal power plant in Spain, where we measure and monitor the temperature of up to 700 degrees. And the process management and optimization, which is running there, is very well done. And we monitor with FBG system point-wise in this stage the pipes which are leading in the power plant. So you can see the front where the sensors are put on and the backs. And as you can imagine, the space in all these kind of implementation places is very small. So one of the really big challenges is how can we install all the sensors in running systems, in running plants. So here a picture which shows how difficult it can be to manage putting the sensors on the right place. Outside the high temperature areas, we have, of course, the splice box and the used interrogation units. To show the advantages or the same results, it shows on the left side the changes, temperature managed by the thermocouples. It shows the degrees when the boiler is switched off, and the same results you get by fiber sensing. Another application is to detect leakage for district heating pipelines, which is also a very important point. A lot of losses can take place as the pipelines are installed for a long time. So it's warm water leak, it's water heat, and so on. Applications to think of these pipelines are natural gas, district heating, drinking water, and wastewater. So we are talking about technical advantages. The fibers are unaffected by radio frequency interferences, immune to electromagnetic interference, and single point sensor or multi-sensor layer. On the safety, we have the intrinsically safety and the installation at hard to reach or view places by other sensors. And of course, monetary reasons to have advantages by using fiber optic sensing. We have the lowest cost per kilometer at fully distributed measuring and per points of measuring with quasi-distributed. And one should not forget that distributed measuring from one end is also a very big advantage. To highlight some of the comparison in between fiber optic and electric sensors is that the immunity against electromagnetic radiation and explosion safety. The point is, in a lot of these applications, it's very critical that you don't have any, or you have spark-free area, which we experienced when we were, for example, visiting a refinery, where it was very critical question where to put all the systems. And of course, not to need any electric power at the point of sensing. What is the development status? So up to a degree of 300 degrees Celsius, we have good experience, we have developed, and it's at that advanced status. Up to 600 degrees, there are very few single projects running. But above, and that's the new challenge, there are exists a fiber that can withstand all these temperatures, but the whole system of monitoring and so on is still under development. And of course, because of special fibers, we know that a heat of up to 2000 degrees should be able to withstand, but this is really R&D development. So, challenges because of these ultra high temperatures exist as well. The heavy stress which is caused by this ultra high temperature is or can be damaging the fibers. And especially because the strain of the material is different from the expansion coefficient of fiber sensors. To manage this by continuous monitoring and distributed temperature monitoring is one of the critical points. In many times we have the combination of the high temperature and the high pressure. So we have to cope and protect the fiber itself. And therefore a very special coating for the fiber is needed. You can imagine that the acryl coating and so on is not really very useful in these cases. And as this is very new, we have no experience in the aging of the optical fiber. But we have good expectations. It should run in the practical field like others, but we do not know how long it will withstand these ultra high temperatures. And of course, because of these high temperatures, we have an increased loss in combination to the length. And as I mentioned before, many of these places where we are going to install these sensors, they are difficult to reach places. What are the requirements now? These ultra high temperature metal tubes can provide the protection to the fiber. So especially in mechanical and chemical protection, this helps very much. Specialty steel material and optical fiber coatings, which are not standard, cope with the high temperature. And special fittings and installation techniques are used to cope with these high temperatures, because often it's in a very demanding environment. And still to be developed are accessories that can withstand temperatures up to 800 degrees. As my colleague mentioned and explained already these measuring principles, I just want to strain the last one. If you think of a furnace, let's say for metal refinery or things like this, you have a furnace like a ball, and when you use this distributed sensing, you can put the wire around the furnace, and you can really detect at any point of the furnace the temperature. That is very important for improving the process and the efficiency inside what happens inside this furnace. So therefore, these kind of advantages that provide the fibers are very well used. So what are the focuses of NBG in this ultra high temperature industry? And why can NBG provide solutions? We have extensive know-how in fiber optic solutions yet. We have experienced in many fields our competitiveness, and we know a lot about this fiber optic sensing right from the beginning. We invest in development, also co-funded by research projects on an European level. We have an excellent and very well equipped in-house testing center that no one else can provide. And we have vast experience in materials and methods through the NBG group. So we are really very well prepared to provide you with the right solutions. So what kind of industries are in our focus? First of all, oil and gas. We have the manufacturing industry. We have the process industry and geothermal industries that are using ultra high temperature applications. And we are very well, or you are very well welcome if you have other ideas where you would think of using ultra high temperature sensing methods. And I would like to invite you to join us for projects together. Thank you very much for your attention, and we are looking forward to develop this new area of fiber sensing.